All right, happy Monday, everybody. Welcome to the linear function and learning about slope and continuing our study in functions where we are modeling and predicting change because the only thing constant in life is change. And what we're going to be learning about this week is the constant rate of change that we find in the linear function. So, what I basically want to do here is make sure you got everything out of the first two videos that I wanted you to get. So first of all, a positive slope is a line that looks like this, and it is a line that is increasing from left to right. And whenever we look at a line or the graph of a line, we always read from left to right. Just like you read a book and words on a page, you read it from left to right. So from left to right, that line is increasing. And from left to right, this line here, the negative slope, is decreasing. Now, if we move on to the next two examples that we had in our video of slopes of lines, we have here the zero slope line, which is the horizontal line, and this is a constant. And then we also have the undefined slope, which was our vertical line. All right, so we'll learn more about these in the future, but these are the four types of slope that we have. Now, if we move on then to our slope reference sheet, we're going to learn how to read and compute slope from a table. And remember, a table of values is nothing more than an arrangement of ordered pairs that can be used to graph a line. So when you're looking to compute slope from a table, you're going to find what we call the pattern of the x and the y values, and then you're going to write slope as a ratio. And the slope ratio is y over x, or this is the Greek letter delta. I know it looks kind of like a triangle symbol, but it's the Greek letter delta, and it stands for change in y over change in x. Okay, so you're going to see me using that notation quite a bit as I teach this unit, and you'll see it a lot in the rest of your math career, that change in y over change in x. So when we look here at a table of values, we have our x and our y values. And let's say I list here 1, 2, 3, 4, and 5 on this side of the table, and then 2, 4, 6, 8, and 10. And what I am trying to do here is to find the slope of a line from this table. And remember, slope describes the steepness of the line. All right, so write the word steepness here. Slope describes the steepness of a line. So the way I'm going to do this is, again, I'm going to look for the pattern. So if I look here at my pattern, my y's are 2, 4, 6, 8, and 10. So my pattern here is a plus 2, or they are increasing by 2 each time. So if I was going to write a ratio here for slope, my change in y then is going to equal 2. And then for my change in x, my pattern is plus 1. So change in y is 2, change in x is 1. So that means the slope of this first table is going to be 2. Or in our linear function, as we see down here, y equals mx plus b, m is my slope or my rate of change, so we would write m equals 2. Now, if I look at the next table, I'm just going to erase that so it's out the way and I don't confuse anybody. My next table, if I have x and y, And at this time, I write my numbers -3, -6, -9, and -12. And then on my y values, I have 8, 12, 16, and 20. All right, I'm going to do the same thing. I'm looking to write a ratio of the change in y over the change in x. So my change in y values, I count 8, 12, so that's +4. My pattern again is 12 plus 4, which is 16. And my pattern again is 16 plus 4, which equals 20. So my change in y is going to be 4. Now let's look at my change in x, because I have -3, -6, -9, -12. So those are changing by a -3 each time. That is their pattern. -3, -6, -9, -12. So that would mean that my slope of this particular line is going to be a -4/3. So in that second example, m is going to equal a -4/3. All right. So that's how we find slope from a table. It's basically looking at the pattern that you see within the table, writing it as the change in y over the change in x, and it's a ratio. Now, the big mistake and the common mistake a lot of people make when computing slope is because we read a table of values x, y, they want to put the change in x over the change in y. But that's not how you want to do it. You want to put your change in y over your change in x. Okay? So that's how we do slope from a table. And then just real quick, if you look down below at the slope from an equation, okay? So when you read an equation, this is y equals mx plus b. This is the linear function or the linear model where we are solving the equation for y. And slope is the rate of change. Therefore, it is next to the variable x. Slope is the coefficient, so that's coefficient. So slope is the coefficient of x. Okay, so we see here y equals mx plus b. So y is going to equal 1/2 x plus 4. So in this equation here, the slope or the rate of change is 1/2. If I have y equals -3x minus 2, same thing, my slope or my rate of change is going to be the -3. So y equals 16x plus 10. Same thing, my slope or my rate of change there is going to be 16. So in the linear function, slope and rate of change are used interchangeably. So if you hear one term used, you know exactly what we're talking about when we use both terms. All right, so what you've got for today is the slope in a table maze. And you're simply going to do what we've already been doing, is you're going to look at the pattern of your y values and the pattern of your x values and write the ratio as a change in y over a change in x. Okay? So if you have any questions, you can see me on Google Meet, or also you can email me and I will help you out. So have a great day, everybody, and we'll get back to slope again tomorrow.